start us off, we're going to go over some basic notes, which are really going over the key features of a polynomial function. So if we can understand what the key features are and how they relate to the equation, we can then use those in order to graph. So this is kind of that middle step there. So one of the first things that we always need to be able to find is the degree of our polynomial, because that's going to tell us a lot about our number of zeros and about our end behavior. So the degree of the polynomial, when it's in standard form, is the largest exponent on the variable. So I'm actually going to make that edit right now. So this is when it's in standard or simplified form. So that's just looking for the largest exponent. This is how we see it most often. However, when we get into larger polynomials, higher degree polynomials, oftentimes they'll go ahead and give it to us in factored form. If that's the case, a reminder that the degree is the number of linear factors. And so that does mean that if you have a factor repeated, so you have x plus 2 cubed, then you really have that one 3 times. Now, the first reason the degree is important because it helps us relate to the number of zeros. The fundamental theorem of algebra says that the degree is equal to the number of roots that a function has. And we know that as long as a root is not repeated, or as long as a root is not imaginary, it creates a 0. So therefore, our number of zeros is always going to be up to the degree. We know we could have less, once again, if you have that repeated root, or if you have an imaginary root, but you cannot have more than the degree. So if I have a third degree polynomial, a cubic, I'm going to have up to 3 zeros. The next piece of what we look at is the end behavior. And notice you're going to see out to the side, it talks about the degree again. But before we get to the degree, we're going to talk about positive and negative leading coefficient. So if we have a positive leading coefficient, it's always going to impact our right-hand side. So as x goes to infinity. Well, positive leading coefficient says that that right-hand side is going to go up. So y will also go to infinity. Once again, positive leading coefficient means that right-hand side goes up. So as x goes to infinity, y goes to infinity. We can have the converse with a negative leading coefficient. Once again, leading coefficient impacts the right-hand side. And here, if it's negative, it just means that our y is going to go down. So it's going to go towards negative infinity. So notice for each of these, I put it where x goes to infinity. Once again, that's just stating the right-hand side. If it's positive, that means the right-hand side is going to go up. If it's negative, that means the right-hand side is going to go down. The other side of this, though, is that idea of even and odd degrees. So if you have an odd degree, that means that your ends go opposite. So in this case, here, if it's going up, then an odd degree means that the left-hand side is going down. So they're going to go in that opposite direction. And here, once again, the right-hand side is going down. So to go on the opposite side, that means that left-hand side is going to go up. So we start with that leading coefficient to determine what the right-hand side is doing. And then if our degree is odd, our left-hand side goes in the opposite direction. But if our degree is even, that means our ends do the same. So my right-hand side here was going up. It's an even degree. So that means the left-hand side is also going up. Here, my right side was going down. Even degree means that my left side is also going to go down. So just a quick review. Once again, we start with that leading coefficient, determine what your right-hand side is doing. Is it going up or is it going down? If you have an odd degree, your left-hand side does the opposite. If you have an even degree, it does the same thing that your right-hand side was doing. So that's our end behavior. So we've talked about number of zeros. We've talked about finding the degree. We've talked about the end behavior. The other key information that we like to talk about is domain, range, and then intercepts, and we'll get down here. The domain of every polynomial ever is always going to be negative infinity to infinity. And that's because for a polynomial, we're just raising some number to an exponent. And any number can be multiplied by itself any amount of times. So any number is going to work here. We're good to go. When it comes to the range, we're saying how far up or down are you going? Well, notice once again for an odd degree, we're going all the way down and all the way up, or all the way down and all the way up. So for an odd degree, the range is all real numbers again. It goes all the way up to positive infinity and down to negative infinity. Your even degree, though, notice either we're going up to positive infinity or we're going down to negative infinity. For each of these, there would be some minimum or some maximum. That would be that restriction. So we know that if it was a parabola, it might look like this. This would be my lowest point, and that is where my range would be restricted. So this one, say that this is 3, -2. My range would be from -2 up to infinity. Or say that we have some quartic, and maybe it looks like this. My highest point here, let's say that this is 5, 7. That's my highest point, and it's going down. So here my range would be from negative infinity up to that highest point of 7. So if it's an even degree, once again, if it's an even degree, because it's not going to, the end behaviors go in the same direction, there's always going to be either a highest point or a lowest point, which means that our domain will be, or sorry, our range here will be restricted. The last little part that we need to know about a graph are their intercepts. And this multiplicity is going to go in here with our x-intercept. So let's do y-intercepts really quickly to get us started. Our y-intercept is always written as 0, y, and that is because it is where x equals 0. In standard form, this is just your constant. Or you can always plug this in and find it. So say that I had y equals 3x squared minus 8x plus 2. My constant is the number without an exponent, and so therefore my intercept here would be 0, 2. That's a really great example for us there. On the other hand, we have our x-intercept. Another word that we've been using for this is zeros, and we even saw that earlier. So x-intercepts is the zeros. This is the opposite. This is where y equals 0. So it's always going to be some x value, 0. Once again, it's where y equals 0. More often than not, you're going to need to be able to factor to get here. So we find this by rewriting your equation in its linear factors. And then we solve each of those out to find out where we're actually going. So say that I had x plus 2, then I would have x equals -2 as a 0. So -2, 0 would be my example there. Now, we talked about earlier, I said, well, you could have a repeated root or a repeated factor. When this is repeated, so say that this had been x plus 2 squared. If this had been repeated, that is known as a multiplicity. So our multiplicity is the number of times a factor is repeated. A factor, I don't want to say comma root or slash root because we know every factor has its own root. The number of times a factor is repeated. And not only is this is the definition of what it is, but it's important because it affects the shape of your 0. So if we have a multiplicity of 1, then your 0 actually looks linear. Or looks, a lot of people just call this normal. It just crosses your x-axis. Nothing weird happens. It just crosses your x-axis like you're used to been drawing graphs, any type of graph you've ever drawn before. So multiplicity of 1, you just have it once, it just goes through your x-axis. Versus if you have a multiplicity of 2, well, that means it looks quadratic. Another way that we say this is it turns around. It touches your x-axis and then it turns around. So it comes down, hits the x-axis and turns around. Or it comes up, hits the x-axis and turns around. So that would mean that your multiplicity is 2. That means you have that factor twice. And last but not least, we have a multiplicity of 3, which if multiplicity of 1 looks linear, 2 looks quadratic, well then 3 looks cubic. We also sometimes call this a squiggle, which is not the best terminology here, but it looks like this. It comes up to your x-axis, it kind of flattens out and then keeps going. So it does actually cross in one specific part, but it kind of flattens out as it does that. So another way, that was not my best drawing, but here it would kind of flatten out, slow down, cross, and then keep going in a steeper way. Whenever you see this kind of shape, that means that you have that on 3 times. So there you have it. These are the key features of a polynomial. And being able to put all of these pieces together, and which we'll do in the next video, or one of my other videos, you'll be able to see this is how we graph polynomial functions.